Longitude and latitudes, shortest distance along the Great Circle, Kcse 1994, paper 1, question number 18. Points A and B lie on a parallel of latitudes 40 degrees north. The 2 points lie along the longitudes 20 degrees west and 100 degrees east respectively. Calculate A, the distance from A to B along the parallel of latitude. B, the shortest distance from A to B along the Great Circle. Radius of the Earth is given as 370 kilometers and pi is given as 22/7. So that is the question. Let's go to the solution. So we shall begin by drawing the location of those places on the globe. We locate the places. Both of them lie on the different latitudes and on the same different longitudes but the same latitude. So that is the longitude 100 degrees east, that is a longitude 20 degrees west, and then both of them lie on 40 degrees north. So that is point A and that is point B. So those are the locations of the places. Now let's go to the first part of the question that requires us to get the distance AB. That is a distance along the parallel of latitude, or distance along the small circle. So distance AB is distance along the parallel of latitude. So to get that distance, we need to identify the formula, and the formula we use to get that distance in kilometers is theta over 360 multiplied by 2 pi r cosine of alpha. Now let us identify what is theta and what is alpha. So theta is where theta is that one represents the longitude difference between the 2 points. There's the longitude difference between the 2 points, and then we have alpha, which is the latitude angle, and this one is 40. In our question is 40. They lie on the same latitude. So theta, therefore, the longitude difference is obtained by, you can see one is 20 degrees west, the other one is 100 degrees east. So to get the longitude difference where we have both points on opposite sides, we add. That is going to give us 120. So when we get that, we get the latitude angle is the common latitude where both of them lie, and they lie on 40 degrees north. So alpha is 40 degrees north. So therefore, after obtaining those values, we need now to substitute them in that formula, theta over 360 multiplied by 2 pi r. So when we substitute those values in that formula, this is what we get: 120 over 360 times 2 times pi times the radius of the Earth, which is 370, then multiplied by cosine of alpha, which is cosine of 40. So work out these using a calculator, and when you do this correctly, you're supposed to obtain, work it out, and you get this one should give you 10,224.139 kilometers. So that is the first part of the question. Now let's go to the second part of the question. So part B of the question, the shortest distance AB along the Great Circle. So I want us to calculate that distance AB, the shortest distance AB along the Great Circle. So in solving this part of the question, there are two methods that we shall use, and we want to pass through the center of the Earth. So we shall create the radius of the small circle, that is small r, and then the radius of the great circle, center O. So we shall use this distance along the great circle. That is why we need, so this center, the center of the small circle, we call that M. And this is the radius OB, is the radius of the great circle. That is the radius of a great circle. The other one, AO, also is the radius of the grid circle. So we need to extract that so that we can see it properly. So we need something like this. This one is just to help us understand how we arrive to that. So as you can see from this diagram here, we have two methods, as said, but we're going to start with the first method. So here is the center of the small circle. Then we have the longitude difference of the small circle. The common latitude is there. This one is a BD. This one is to help us understand how we're going to solve this question. So when you look at what we have, let us sketch the diagram now from the question that we have. So that is the radius of the small circle, which is r cosine of theta. That is the radius of the small circle. And then we have, that is distance AB that we have. This diagram on the left hand side, this one, is to help us understand how we arrive to this, how we are going to calculate. So the radius of the grid circle is given as 6370 kilometers. Then the small circle is r cos theta. So we're going to draw a line that divides these triangles into two equal parts, meeting at this point, which is 90 degrees. So having this diagram will help us get the angle at the center of the earth. This angle that is here, the center of the earth at C. So we have the longitude difference, which is given by 120. That is the longitude difference. We had calculated this earlier on. One is 20 degrees, the other one is 60. So when you divide this line divides this angle into two. So this will be 60 degrees. So we can call that point, you can name it as BT, you can name it as T. We can just, because the center of, no, not M, I think it should not be M. We just need to have it as T. Let us have that point as T, because we have M is the center of the small circle. So now look at this triangle ATB. That is what you're going to use to help us calculate this side 8 AM. So looking at that diagram, we need to calculate the angle at the center of the earth. That is our main interest in this question. That will help us get the distance along the grid circle. So we need this angle at O. That is the angle that we need to calculate. So we need to go through everything that will help us calculate that. And to do that, we shall extract a triangle from that figure. Look at triangle AMT, where we have that angle as 60. This is AM. When you get AM will be very important because it will help us calculate. So we have, look at where we have extracted it. So that side AM is what we don't have. That is what we need to calculate. So don't forget, AT is the radius of the small circle, which is given by r cosine of theta. And don't forget that in this case, theta is the latitude angle, which is given as 40 degrees. Then the radius of the grid circle is 6370. Therefore, we can obtain this length of 80. So r cosine of theta will be 6370 cosine of 40. When you multiply out that, you arrive at that is 4879.7 kilometers. So that is that distance. Now that is the radius of the small circle. Now when you get that, now it will be easier for us to get, since this one AMT is right angle triangle, to get AM we shall use trigonometric ratios. And in this case, the best trig ratio to use here, since we have the hypotenuse and we also have this angle, to get AM we shall use I think sine will be better. Sine I think sine will be better. So sine of 60, I think sine of 60 is equals to the opposite, which is AM over the hypotenuse, which is r cosine of theta, which we got as 48. So sine 60 is equals to AM, is what we don't have. Then 80, we have 80 as 4879.7 kilometers. So we multiply both sides by 4879.7 and we get AM as 4879.7 multiplied by sine of 60. So when you multiply that, this is what we get. When you multiply, we should get so we get 4225.9468 kilometers. So that is the length AM. So now we've got AM, the length of AM. Now it will be easier for us to get, look at AM, where AM is in this figure that is here. So AM is the same as MB. So since that one is the same, let's now use triangle AOM to get the angle at the center of the earth, because that is what we need in order to help us calculate the distance along the great circle. So look at triangle AOM, which is that triangle. When you extract it, this is what we shall get. That is where the right angle is at A, that is M, and this one is O. So we have now we have the distance AM. We got AM. We can put the length of AM there, rounding it I think right the way it is. And then that is the angle. We need that angle, and once to get the whole of that angle, we just need to multiply by 2. So the radius of the great circle OA, that is the 6370. So upon drawing that diagram, now we can use Pythagoras theorem, or no, not Pythagoras theorem. I think to get that angle, we need to use sine. Sine is okay. So we get sine of that angle is equals to opposite, which is 4225.9468 divided by hypotenuse, which is 6370, and this will give, when you divide, when you do that division, you get 0.6634. And to get now the angle, we need to get the sine inverse of both sides, and sine inverse of 0.6634 will be, get the sine inverse, that will give 41.56. So that is what you get. Now that is that angle AOM is the same as the other angle, which is MOB. So to get the whole of that angle, we just need to multiply by 2. So the whole of, to get now the whole of that angle at the center of the earth. So angle AOB, therefore, which is the whole of that angle, you can see it, AOB, So that is 41.56 multiplied by 2, and that will give 83, to give 83.12 degrees. Now we have obtained the angle at the center of the earth. Now let's now calculate the distance, the shortest distance along the great circle, that is distance AB along the great circle, and it is given by this formula: distance along the great circle, theta over 360 multiplied by 2 pi r. That is how we get the distance along the great circle in kilometers. So now we have the angle at the center, which is 83.12 multiplied by 2 by pi by the radius of the earth, which is 6370, and that gives 9244.7. I think we can write it up to 2 decimal places, 0.79, which is approximately correct to number that will be 9245 kilometers. So that is the first method. Now we still have another method. So method 2, we shall use a certain formula, and this one is the shortest way or possible way to get the same distance along the great circle. And this formula goes like this: sine of half beta is equals to sine a half alpha multiplied by cosine of theta. So that is the formula that you're going to use, where beta is the required angle, the angle at the center of the earth. That is the angle that will help us get that distance. And then we have the other angle, which is alpha. Alpha is the longitude difference, of which we know in this question, the longitude difference of the two places, which is 20 plus 100. We had got this is 120. And when you look at the figure here, you can see the longitude difference, and then which is 120. We had got that. And the next thing that we need to get is the latitude where the two lie, which is represented by theta. That is the latitude angle, where the common one, they lie on 40 degrees. So now having those, you can see now the unknown. You can see the unknown. That is 40 degrees north, the latitude, where they lie. Now having everything there, now you can see that we need to get beta. Beta is the angle that we need. So we substitute those values in the formula. I have this sine I have beta is equals to sine of half multiplied by the longitude difference, then multiplied by the cosine of the latitude. So when we get that angle beta at the center, now we shall use now the formula of getting the distance along the great circle using the formula that we've just used in the previous part. So sine I have beta is given by, this is sine of 60, a half times 120, that is 60, multiplied by the cosine of 40. So this will give sine of half beta is equals to sine of 60 multiplied by the cosine of 40. Sine of 60 multiplied by cosine of 40 will give 0.6634. That is what you get. So you have half beta. When you get the sine inverse of both sides, in order to get beta to remove the beta, you get the sine inverse of the left hand side and the right hand side. You made with the half beta is equals to the sine inverse of 0.6634, which is 41.56 degrees. And this gives beta is 41.56. You can see we've got the same answer as the previous part. So that is the angle at the center of the earth. When you want to get the whole of that angle, again we need to multiply that one by 2. Now the reason why we are multiplying by 2, is because you can see we have a half beta. So to remain with beta, you multiply both sides by 2. So therefore, the distance AB, since we had already calculated this, now we have the angle at the center. It's just a repetition of the previous part, which is beta, which is 83. We got 83.12 degrees divided by 360, multiply by 2 by 22/7 times the radius of the great circle. We had got these in the previous part. So the second is an easiest method, where you just need to recall this formula. Once you do that computation, you just get the same answer that we got for this part, which is 92.45. We got that one is 92.45. So those are the two methods that you can use to calculate the distance along the great circle. Now, the two methods are very useful. You have to decide which is the best method that suits you. So thank you so much.